Today, the topic of our lecture is three-phase induction motor and its application. We shall study what is the three-phase induction motor and for what purpose it is used. Overview. The overview of our lecture is first introduction, then components. After that, construction of the induction motor we will study. After that, at which principle the induction motor works we will study, and after that, application, advantages and disadvantages of the induction motor. A three-phase induction motor is a rugged self-starting electromechanical device that converts electrical energy into the mechanical energy by using the rotating magnetic field generated in the starter to induce the current in the rotor, causing it to turn. Induction motor is basically a device which converts the electrical energy into the mechanical energy by using the magnetic field generated in the starter. These widely used industrial motors are known for their reliability, efficiency, low maintenance needs, and simple construction, making them ideal for the application like pumps, fans, conveyors, and industrial machinery. Motor basically converts the electrical energy into the mechanical energy by rotating magnetic field in a starter. In the induction motor, there is a starter and the rotator. On a starter, there is a magnetic field which is called starter magnetic field, and on the rotator, there is a magnetic field which is called the rotator magnetic field. The speed of the rotator magnetic field is slightly less than the starter magnetic field, which produces the torque in the motor, due to which the induction motor runs. Components. Components of the induction motor is frame, starter winding, rotor winding, cooling fan, and bearings. This is basically the component of the induction motor which is being shown on a pic. This is basically the driving end shield. This is the terminal box. In this terminal box there are basically three connections to which red, yellow, blue cables are connected. Three cables, red, yellow, blue, are connected to these three connections in the terminal box to give the induction motor three-phase supply. And this is the motor shaft. This motor shaft is coupled with the pump to drive the pump, and there is a bearing which is used for the rotation of the smooth operation of the shaft. This is starter, this is mounting hole, this is enclosure. Enclosure is basically the main body of the induction motor that encases it and protects it. This is the base and foundation. This is a rotor and bearing. This is fan cover. This is fan cover, and inside the fan cover there is a fan which rotates and gives cold air to the induction motor to prevent it from the heating. This is non-drive shield, starter winding, rotor eyeball, and the rotor bear. And this is basically the base which is connected to the foundation. If suppose base is not firmly connected through the bolts, then the vibration can be produced in the motor. Therefore, while assembling the induction motor at the base, nuts should be tied correctly to prevent the induction motor from vibration. The three-phase induction motor consists of two major parts. A starter, it is a stationary part of the motor, and rotor, it is a rotating part of a motor. This is a starter and this is a rotor. A three-phase induction motor works by using the Faraday's law of electromagnetic induction to convert the electrical energy into the mechanical energy. As we know from the physics law, from the Faraday's law, when the magnetic field or magnetic flux around the conductor changes, then the EMF across the conductor is produced, which the electric current produced in that conductor. In this principle, induction motor basically works. A three-phase AC supply to the starter creates a rotating magnetic field which then induces the current. The three-phase supply is given to the starter, which produces the rotating magnetic field and induces the current to the rotor, and the magnetic field established in the rotor. Now the two magnetic fields are produced when we give the three-phase supply. When we give the three-phase supply through three-phase cable to the motor, then two types of magnetic field are produced: starter magnetic field and the rotor magnetic field. The interaction between the starter's rotor magnetic field and the rotor magnetic field produces a torque, causing the rotor to spin at a speed slightly less than RMS synchronous speed, phenomena known as a slip. Now we have two magnetic fields, starter magnetic field and the rotor magnetic field. So the speed of the rotor magnetic field is slightly less than the starter magnetic field, because which the torque produces and the induction motor runs. And this difference in the speed between the rotor magnetic field and the starter magnetic field is known as a slip. This is the most common question that can be asked by you at the time of an interview, that what is slip. If you give answer in just one statement, that the difference in the rotor magnetic field and the starter magnetic field is known as the slip of the motor, then your answer will be the correct. This is the working principle of the three-phase induction motor, which has been tried here to shown on in a pic. The three-phase AC supply is given through a three-phase cable red, yellow, blue to excite the starter. Now the magnetic field is produced in a starter, due to which it reduces the current in the rotor. As the result, another magnetic field is produced in the rotor, and the rotor magnetic field is also rotating here, but the speed of the rotor magnetic field is slightly less than the speed of the starter magnetic field, due to which the torque is produced. And this difference in speed, as I have told you before, that is known as a slip. Difference in the speed of the starter magnetic field and the rotor magnetic field is known as a slip. Application: induction motor is mostly used for the pumps and submersible, pressing machine, lathe machine, grinding machine, conveyors, floor mills, and the compressors. This is basically the industrial application of the induction motor, which has been shown here. Advantage: now we shall discuss what are the advantages and the disadvantages of the induction motor. Induction motor is for low cost, simple design, high efficiency, low losses, and less maintenance. These are the advantages of this induction motor. And one of the basic advantage of the induction motor, which can be asked as a question by you at the time of interview, is that most of the time the interviewer asks the question that why we use the induction motor in the industry, why not we use the synchronous motor. The answer to this question is that the induction motor is a self-starting motor. However, other types of motor like a synchronous motor, they are not a self-starting motor. This is very tricky question that are mostly asked at the time of interview in your job position by your employer. And there obviously, if there are some advantages of an induction motor, there are also some disadvantages of an induction motor. Poor torque, difficult speed control, lagging power factor. Speed control of an induction motor is very difficult, because of which we have to use the VFD in the industry to control the speed of the motor. You know, VFD, variable frequency drives, are used in the industry to control the speed of the induction motor. And another great disadvantage of our induction motor is that its power dissipation is very high, and due to which its power factor lagging. Induction motor are used in the industry, as we know that because of which the power factor decreases from the utility, because of which the capacitor banks are used in the substation. And if the induction motor are used for the domestic purposes, then the power factor are installed in the grid station, 11 kV, 33 grid station, by the utility companies. Therefore, this is one of the disadvantages of a induction motor. Thank you. Please like and subscribe our YouTube channel. Thank you.